Let's practice using the very last equations you will learn in this course. In the ocean, the average wavelength of a series of waves is 15 meters. So we know that this is wavelength, and that is the lambda. It's a Greek symbol. The frequency of the ocean waves is 0.15 hertz. What is the average speed of the waves? Make sure that that is a lowercase v, not a capital. Your wave speed equation is that speed is equal to wavelength times frequency. So we don't need to rearrange this equation at all. We know that velocity equals 15 meters times 0.15 hertz. And you might want to remember that hertz just means per second, or that if it makes you happier. So when you do this math, you see that the velocity is 2.25 meters per second, which is the correct units for velocity. Let's look at example 2. Green light has a wavelength, we know it's lambda, of 5.20 times 10 to the negative 7 meters. And the speed of light is 3.00 times 10 to the 8th meters per second. What is the frequency? And you're also asked, what is the period? So we have our wave speed equation up here. We can rearrange that to solve for frequency if you need it. Velocity is equal to wavelength times frequency. So if we're solving for frequency, we have velocity divided by wavelength. The hard part about these problems, and dealing with light is always going to have scientific notation, is using the scientific notation and putting it correctly into your calculators. If you don't remember how to do it, you might go back and check in the math chapter at the very beginning of the course. There's a little section about scientific notation, and I give you some directions for how to put it into your calculator. We look at our units, meters cancel out, and we get per second, which is hertz. And I put in 3, and then I hit EE, 8. And when you divide by a number in scientific notation, you have to put, for most calculators, it in parentheses. Otherwise, you do 3 times 10 to the 8 divided by 5.2, and then everything times 10 to the negative 7. So make sure, to be safe, you put that scientific notation in parentheses, and you get a large number, about 5.8 times 10 to the 14th hertz. That's a lot of waves per second, but it's correct. And now you're asked to solve for period. Remember that frequency and period are inverses of each other. So period is equal to 1 over the frequency. So instead of per second, we now have second. And so it takes 1.7 times 10 to the negative 15 seconds for one wave cycle to pass through. And that makes sense. It would take a very little amount of time because the wave is moving very fast, has a small wavelength, and lots of waves come per second. So if your frequency is very large, then your period is always going to be very small, and vice versa. Please try the example problems below and check your answer before moving on to the assignment for this page.